So for example, 1 joule, that would be kg meters square per second square in SI units.
1 Newton meter.
Yeah, so when you simplify it to the basic fundamental units, you would get kg meters square per second square. Now for that, you could change each of them individually. So 1 kilogram would be 1,000 grams. Yeah, like that.
And 1 meter
And then you
square
would
equals to?
get 10 to the power of 7 erg.
Okay, 1 meter square equals to how many centimeters square?
Sir, it would be 10 to the power of 4.
Okay.
So 10 to the power of 7, and then it would just become ergs.
Yes.
Yeah, that's great.
Which is 10 to the power 7 erg. This is your first conversion. Now, who else can answer for second one?
Or can I?
Wait, let someone else try. Anyone?
Yes.
Yeah.
Okay, so as we know, in the gravitational constant is G(m1 m2 by r square).
Oh, F equals to?
Yeah, that's a force. So if we take the G other side, then we can get from there. Then G will be F r square divided by m1 m2. So as m1 m2 is there, that is a unit, basic unit, and so we know that it will be m to the power minus 2. And force we had already calculated, right? So force equals to mass into acceleration. Acceleration equals to L divided by second square.
No, I just want CGS units.
Okay, sure. Just one. So what you say you want CGS units?
Yes, dear. I just want CGS units.
Okay.
kg meter per second square by
Sir, it would be
by kg
By kg.
and then another kg.
Okay, that means kg square.
so
So
can
sir,
I
it would
answer?
become kg power minus 1,
Okay.
and then meters.
Sir, m minus 1 L3 T minus 2 will be the answer.
नहीं बच्चा, पर हमको dimension नहीं चाहिए. We want CGS units only.
Yes, sir. So then
Okay, so
once you get everything in kgs and meters, you can convert that to CGS units the way we did before. So 1 kg would be 1,000 grams.
So will it be like this? Meter cube
Yes.
by kilogram second square.
Yes, sir.
Okay.
And then now it would be, since it's meters cube, we need to change it to centimeters.
Mm-hmm.
10 to the power 6 centimeter cube.
Yeah, and we can convert this. This is what 10 to power 6 centimeter cube, then 1,000
1,000 into seconds.
into seconds.
That's one.
Yeah, that means that
So
is
you would get 10 to the
1,000.
power 3 centimeters
Yeah,
per
10 to the
gram
3 will
second
be
square.
remaining.
Okay, guys, for tomorrow's test,
Or
shall
shouldn't
we?
it be centimeter cube?
Oh, yeah, I'm so sorry. It should be centimeter cube. I posted as units and dimensions, but shall I give you a test on physical world? It's just like
No, sir. You can add just the derivative questions also.
see, like what I'm saying. In this physical world, we have what, like who made this one, who discovered that, all about physics.
Sir, units and dimensions are fine, sir. For me.
You want units and dimensions only?
Yes.
Yes, sir. I haven't done that chapter yet. That's
No, like it's just easy chapter. That's why. If you read once, it will be over.
But say we need to remember those names. That's why
yes,
that
sir.
would be a problem.
Yeah, that's true. Okay. So like Einstein got Nobel Prize in what? Like that. Special theory of relativity, general theory, and photoelectric
Sir, it'll
effect,
take
or
some time to
whatever.
remember, right? So we'll maybe do it in the next few weeks.
Okay. So do you remember who discovered X-ray?
X-rays. Was it Rutherford?
No. Okay, then leave it. Okay, then let's come back to our units and measurements. Now here, first question we are going to do here, check the correctness of that question or formula. Question number one. No, let's do some others. Okay, let's try, no problem. What is it? Check. Accuracy or correctness of a formula. So it is given here. But for that, you should know all the dimensions of all the quantities. That will be the problem. Okay, so before that, shall I give you a list of the dimensions of constant? Because we haven't studied those things. So I'll give you a list of dimensions of constant.
Okay.
Okay.
For now, you remember it, but later on, while we are studying chapters, it will come. We will derive those things, actually derivation. Okay. For time being, you learn it.
Yes.
So let's see, surface tension we haven't derived. I think so. So let's erase
We
this.
did it in the last one.
Did we derive a surface tension?
Yes. Sir, it's a rho G RH by 2.
Yeah.
All right. Yeah.
So let's start with torque itself.
Sir, we
Sorry?
did torque as well. It's force into angular distance.
Yeah. Force into perpendicular distance. So dimension will be M L2 T 1 and 2.
Minus 2.
Minus 2. Minus 2. Yeah. 2 will be added here.
Yeah, -2, yeah.
So surface tension. S equals to force per unit length. So it will be M T minus 2.
Sir,
Yes.
how come you gave something else yesterday?
It's same. Check.
So
Agree.
F by L is the same thing as rho G RH by 2.
Yeah. Formula we are deriving in different manner. Answer
Okay,
will be same.
So
See,
can you?
dimension are same. See, M1 L T minus
Yes.
2. I'm just giving formula like which is short to remember. Okay, then let's take potential. Gravitational. Sure. See, instead of writing all this 50 quantities, it will take so much time. Shall I take a picture and post it here? It will be better. Where's my phone? Because if I keep writing, then whole class, I need 2-3 classes to finish this. Instead of that, we can utilize in different way.
Yeah, you can post it on WhatsApp.
Yeah.
Grab it.
I'll make a PDF, just to give me a minute. No to memorize, okay? Just take help of it. That's it. When we are solving it, take the help of that. Just a minute. Let me.
Sir, the formula for gravitational potential is mgh, right?
Yeah, W by M, it will be easier.
Okay.
Dimensional, just a minute, please. Formula of okay. I posted there, then we can do numerical now. Share a copy. Where is our group? Yeah, you received, right, everyone?
Yes, sir, got it.
Yes. Good.
Okay. So keep it with you. It will be helpful for you some of the time. Okay, let me move aside. Yeah. Okay, what happened? Yeah. So then no need for this. Just check once. All those quantities, just read once. No need to remember, just read once. Till then, I'll finish a question here, writing. So what we were doing? Correctness. Okay. Check the correctness of following equation. Dimensionally. Okay. Now let's start with how to check. Let's start with on first basic equation. Guys, everyone see here now? F equals to ma. Now we know force, right? What is force? M1, L1, T
-2.
-2.
Let's go with mass. M,
M1.
and for acceleration,
L1 T -1.
T minus 2.
T -2 will be.
Okay. So M1, L1, T
T
minus
minus
2,
It's correct.
and it is a dimensionally correct. Right? Right? I did this easy question. Now I'm going to give you some difficult one. Not difficult, but just I want you to try something different.
So
So
if it is a wrong formula, then how can we? So
no,
should we tell that it's wrong?
if they give wrong, that means something is wrong. Either formula are wrong or dimensions are wrong. I mean formula wrong. We need to check. See, that's what the question is. Check the correctness of following equation
For
dimensionally.
example, sir, you get F equals to R square by M1 M2. That's incorrect, right?
Yeah,
So we will check and then we will tell you whether it is correct or not.
exactly. See, if instead of A, if they give F equals to MV, so which is incorrect.
Incorrect. Okay.
So we have to say this is incorrect form. Right. So let's try something. F equals to NA dV by dx sine theta. Now, what are these quantities? Let's describe those quantities. Where F is force and neta is of viscosity. A is area, dV by dx is
Velocity.
yes, velocity gradient with respect to distance. And theta is angle of contact. Now, first of all, my first question is force dimension we know. And area dimension we know, coefficient viscosity, you can search it from that list. Now, what will be the dimension for angle of contact?
It will be length by time, I guess.
No, dear, there is no dimension for those things. See, keep this in mind or make a note of it. Like trigonometric ratios, all trigonometry ratios, dimensions are M0, L0, T0. Like e to power x. Same goes for M0, L0, T0. Same in log x. Similar. M0, L0, T0. Keep this in mind. So did you find coefficient of viscosity? It's in 11th number if you can't find.
It's M1, L minus 1 and T minus 1.
Yeah, sorry?
M, L1 and L minus 1 and T1. T
T
minus
minus 1. Yes. If you can't find it's number 11th in our list.
Sir, it's incorrect, sir.
Is it incorrect?
Even
Yes, sir.
I'm getting. But
It's
Are
coming
we,
as R equals to sine theta. Sine theta you told M0, L0, T0.
there is no dimension, so we need not to worry about sine theta.
Yes, sir. So
If
it's incorrect.
this quantity correct, that means it's correct. So what is neta dimension? M1, L minus 1, T minus 1. Area, L2. Velocity,
Sir,
LT minus 1.
eta, right?
Sorry?
Use the dimension of eta, right?
Yeah, M1, L minus 1, T minus
Yeah,
1.
M1, L minus 1, T minus 1.
Right? So area is, if I write, let me write here. So force dimension are M1, L1, T minus 2. This is M1, L minus 1, T minus 1. L2, velocity is, no, LT minus 1. This is L. Now I need to divide this, so L will be removed from here. It will be T minus 1, T minus 1, T minus 2. Yes, we have T minus 2, correct. And
So what is it for velocity?
no, dimensions are correct, dear. How can you say wrong? See this? 2, 3. Yeah. This will go 2 minus 1, 1. And M1. Fine, it's correct. Dimensions are not wrong. Let's prove it. So LHS is M1, L1,
L1,
T,
T minus
2. We have this on LHS. Now RHS. What are dimensions? First one, neta, area, velocity by time. Sorry, distance. Neta means M1, L minus 1, T minus 1. T minus 1, right?
Sir, you wrote minus 2.
Which one?
Oh, no, sir, sorry.
Yeah, that's correct, sir.
Correct? Oh, okay. Then area L2. What else we have?
Velocity gradient.
Velocity gradient with respect to distance. So velocity by time, velocity is L T minus 1 divided by L. So here L and L will get cancelled. So total M1 L minus 2, sorry, minus 1 plus 2 plus 1 minus 1. T minus 1 minus 1. So M1 L 1 T minus 2. Yes.
Yes. Sir, I think where I made a mistake is when I took a velocity gradient with respect to time, I only took the top part, not L on the bottom.
Okay.
I mean, why did you take the L on the bottom?
Because with respect to distance. So velocity
That would be
by distance.
velocity by distance. Okay, got it.
If it is with respect to time, then we will take time. That means it is acceleration.
Oh, sir, so I took t minus 2 instead of
1.
1. I got it.
In that list, do we have velocity? Yeah. See, when you're not sure, just try to look it. It's not wrong in that list. Okay. That's why I gave you those 50 lists. Anyhow, nobody can remember all 50. But once you come to across the chapter, those chapters, that time you will learn it automatic. No need to like memorize it. Because right now you're not going to give exam. It's for your next year. So next year you will study those inductance and all that thermal conductivity. Then everything you will be studying. So need not to worry. Yeah. Any doubt here? Everyone, all 5 of you? Aditi, Rahman,
No, sir.
yeah, Shadab, okay. Samarth, Samhita,
No, sir.
Not answer.
okay. Rahman, are you corrected? Okay, fine. Let's try some other method. Now see what we did here. Actually, I'm going to give you some more one step extra. Shall I give first? Thinking. No, you first get thorough with this one. Then I'll go with next thing. Actually, in exam, they won't ask this. What I'm going to do next, they will ask like you have to find out the formula. That is the main part of this chapter. But we'll do that. First, you get thorough with this one. Let's try. One minus cos theta obtained as a m. What is m here? Mass is right. Okay. Velocity. Okay. Yeah, you can try this. Don't get scared with the formula. This formula looks so big. So this is the formula they obtained from a problem or solution of problem. So dimensions to find use dimension to find whether this is a reasonable spelling wrong solution or not. You need to find it's a reasonable solution or not. So where v is velocity. Slow. ठीक है. Velocity, then m and capital M both are masses. L is length. G, acceleration due to gravity. Okay. So let's start with Aditi. First name starts with A, right? Okay. So Aditi, what will be the dimension for acceleration due to gravity?
Velocity by time.
Yes, velocity by time. So dimension.
L1 t minus 2.
Very good. So length, mass, and velocity, you know. Fine, everyone. So what about this 1 minus cos theta and 1 plus cos theta? Shadab?
Sir, there would be no dimension, right? Since any trigonometric ratio would have no dimension, and then a unit simply does not have any dimension as well.
Okay. So first, I want answer from everyone.
Sir, I'm
M1
getting
L
that it's
minus
not.
1.
Sorry. Say again, Samar.
So we have to find the formula of V square, right?
Yeah. No, we don't have to find. We have to
Dimension.
reasonable solution, like they are correct or not dimensionally.
Sir,
Yeah.
Okay.
I'm getting that it is not a solution.
It's not. It's wrong.
Yes, that's what I'm getting.
I don't think so. Without solving, I can get an answer here. Think. Mass and mass will get cancelled. Here, G as meter per second square. So, and length as meter. So, meter square per second square. That side, velocity. Velocity is meter per second. And again, square. So, meter square per second square. That means it is correct.
Oh, wow. I forgot the V squared. I'm taking L1 T minus 1. Okay, then it's right. Yes, sir. Got it.
Now, prove it dimensionally, everyone.
Yes, sir.
Done.
Correct. It's coming to be L1 T minus 3.
Everyone, are you getting? Samhita?
I'm trying it, sir.
Okay.
Here it's coming to be L2P minus 4.
Minus 4.
Yeah, L2P minus 4. Some sort of.
Minus 4 कैसे आएगा?
Sir, V square है ना?
ठीक है. See, this is
I'm getting
M0
L2 minus 2.
T minus
L2 T
1.
minus.
And it is square. That means L2 T minus 2.
Okay, sir, it will be minus 2 actually.
This is your
L T minus 2. That's why I got it.
ठीक है. So this side M1
M1. Then gravitation is same as acceleration, which is L1 T minus 2. The mm will get cancelled.
So if I solve it like this, 1 minus 1 L2 T minus 2. So this is M0 L2 T minus 2. Okay, in exam, if you have descriptive type like this, like I'm talking about your school exam, don't cancel it like here and here. No, this is not the proper method. You have to show this way. But in JEE exam, like, no need. We are our own boss. Okay, so everyone, any doubt?
No, sir, I got it.
Got it? Samita?
Got it, sir.
Okay. Next question is for Samhita.
Okay, sir.
Yeah. So what are types of energy we know?
Potential and kinetic.
Yeah. So formulas for those?
Potential
Wait,
MGH and
Half mv square.
Yeah. Just one Shamita to answer. 1 minute, please. Shamita?
Yes, sir. I'm looking at it. 1 second.
Is it potential energy and kinetic energy? Okay, so what is the formula for potential and what is the formula for kinetic?
MGH is for potential. And
MGA, kinetic energy.
I don't know kinetic energy.
Okay, anyone?
sir half mv square.
See, this both we have unit as joule, right? Energy is unit as joule. Let it be potential, kinetic, or whatever type of energy, mechanical and blah blah blah, all others. Right? Am I right or wrong?
Yes, sir.
Everyone?
Yes, sir.
All energy units are joule. Is anyone having doubt in that? Any objection?
No, sir. No, sir.
Okay, then I want you all to prove this dimensionally. So I want you to prove half mv square is equals to mgh. Super, I got disconnected. Exact time I'm getting disconnected. Exact time I'm getting disconnected. Power cut. Yeah, did you heard what I said?
No,
No, sir. We heard up to prove this, and yeah,
That's
we're
it.
done.
Yeah, that's it. Yeah,
Yeah.
that's more than enough. Yeah, prove dimensionally. Come on.
We're
Done,
done.
sir.
Done.
Done,
Oh,
sir.
oh,
Yeah.
that's good. Is it getting correct dimensionally?
Yes, sir.
Yes,
Yes,
sir.
sir.
Correct.
Completely correct.
Samita?
Done, sir.
Okay, what are dimension for G?
G I took as L power T minus 1.
T minus?
Minus 2. Sorry, T minus 2.
Very good. And H?
H is L.
L, yeah. And mass? M.
Mass is M.
And velocity square?
L2
please.
3 minus 2.
L2. So everyone got this?
Yes, sir.
Yes.
Okay. Rahman, you're saved today, right? You don't have proper internet connection. Yeah. Are you solving? Okay. Fine. Yeah. I know. So we can prove this one. M1 L2 T minus 2
T minus 2.
M1 L1 T minus 2 and here L1. So which is equals to M1 L2 T minus 2. Same goes here, M1 T minus 2. Okay, what about this numeral half? What shall we do with half?
You don't
Half is
consider
a
that.
constant, they not required.
Yes. The constant, a numeral constant or any numeral, they are dimensionless. Okay, this one we did, I think so, right? Let me check. This is the homework. Yeah, we did this one. Okay, fine. Yes, we have enough time, so we can start something new. Okay, so now till now what we did here, we were comparing. First we found, okay, what are the dimensions for those quantity, then we compared those quantity. Yes, is it RHS equals to LHS? Now what we'll do, with the help of one quantity, we'll find out, or we'll find the formula like F equals to MA, right? Let's go with first easy one, always. Okay, this says they didn't give you this formula. Okay, so they will say force is proposed. We know this formula F equals to MA. They will say force is proportional to mass directly, and force is proportional to acceleration. Then how it is proportional, we can find out like this way. Like let's take this example. Yeah, let's solve this question itself. The air bubble formed by explosion inside water perform with time period t. Which is directly proportional to p to power a. Now a we need to find out that a, d to power b, e to power c. Now we need to find this ABC. A might be 1, so it will be above numerator, power 1. B, if it is -1, then it is in denominator. If E is square, it will be in numerator square, like that. Whatever it is, I'm just giving you an example. That we need to find out A, B, C, whatever it is. If like E is 1/2, that means under root E. That's our formula. That will be our formula. That we'll see that. Now, where P is pressure Now D, here it is density. Okay, like they can give any variable and they will mention that here this variable is used for this quantity. Till now we were using rho, right? For density.
Yes.
Here they gave D. So, and what is it? Yeah, E they gave as energy. Due to explosion. Find a value of A, B, C. Okay. You want to give a try? Or shall I give you one hint first? Let's give you a hint. Let's do that first. See, let's take T equals to some constant K proportional to K, PA, DB, EC. Now dimension of K will be M0, L0, T0. So we need not to worry about those. But we should know pressure, density, energy, and what is T? Time period, dimension. So write those dimension for pressure dimension, power A, power B, C. Now get me three equations of one for M, one from M, one from L, and one for T. Do we have any other? Pressure, density, and energy. No, we won't have any other. So one
So
from
can you
M.
explain how you got the first T is equal to K, P, A, D?
See, actually it is not K, it is proportional. T is proportional to P to power A.
Oh, okay. That was the proportionality, constant of
Constant.
proportionality. Okay, yes.
Yeah.
That's fine.
And it is dimensionless. We are assuming that. Here we don't have K, so let it be K. I can use any number, any variable. So compare similar way what we did comparing, same thing you do, but it is in ABC form. Oh, no. I got disconnected again. I got disconnected again. I got disconnected again. I got disconnected again. Again. Am I connected? Can you
Yes,
all
sir,
hear
we
me?
can hear
Okay.
you.
Yeah.
Okay.
Yes, sir.
So a fraction of second power cut and going and coming. What is this? Fine. So try it. I'll solve it. Don't worry. But you first try. Give a try. Get me A value. You will get three equations, right? So get me A, B, and C. There will be one equation for A, one equation for L. Sorry, M. One for L. One for T. Because we know M power 0, L power 0, T power 1. So those ABC of M should be equals to 0. Those ABC of L should be equals to 0.
And T will be 1.
And those ABC of T equals to 1. This way you have to do. This is not exact, I'm writing here, but just for A, B, C, A plus B plus C equals to 0 from all mass. A plus B plus C equals to 0 from length. A plus B plus C equals to 1 from time. So these are not exact values. Okay, you find out. I don't know. I just wrote it. Even I want to check what are the quantities. This is just a hint I'm giving you. Don't write same thing. It's not right.
Sir, I did not get a part of that. Why did you get P, D, and E? Those,
Which one, boy?
sir, P, D, and E. What are they? Actually, I did not get it.
Oh, wait. I'll scroll up. P is pressure. D is density. E is energy.
Okay, okay. Now what?
Any progress?
Sir, I found the dimensions.
Okay. What are those?
For pressure, it's M minus 1, L minus 1, T minus 2.
M minus 1.
Sorry, M1, sir, M1.
Yeah, M1.
Density is M1, L minus
Minus.
3.
Yes. Then energy.
M1, L1, T minus 3.
No. Energy. Again. M1.
L1, T minus 3.
Again.
M1, L1, T minus 3. Sir, is it wrong?
Check again. Do we have that energy in list? Yes. Energy is equals to work
Energy we
done.
did before, right? In that MGH.
Which one?
Sir, energy is in joules. We did
Yeah,
kinetic energy and potential energy.
energy
So,
is equals to work done. Both are same.
okay.
So Aditi, what's work done? See, if you can't remember dimension, no problem. Just formula you know, right? Force into displacement.
ML, yes, sir. M1, L2, T minus 2.
Yes, now it is correct. Samhita, any progress?
So trying to look through.
Okay.
Sir, I got the dimensions. Then do you have to put those values in those brackets, right?
Yeah. So all the M term from all these three brackets, let's take it as 1, 2, 3.
Okay.
And let's give a name as I. All the M from 1 to 3 equate to M of I. Same, all the L from 1 to 3 equate to L of, like how we do in powers, equating powers, right? If base is quantity is same, so powers we can equate like this, like A equals to 0, sorry, X equals to A, then X equals to 1 plus X equals to 2. So I can equate A as 1 plus 2. I can equate as X equals to 3. I can say that X equals to, sorry. So A equals to 3. I can equate this. Right? That same way we can do this. Okay. Don't worry. Let me solve this.
Sir, so in that case, is M1 equal to I?
Yeah. M from all three. First, second, and third. All three we are equating to the M of this one. That is
So
0.
Oh, I got actually -1 + 1 + 1.
-1 + 1 + 1. as
Yes, sir.
M.
Yes, sir.
Okay. Let's see this. M0, L0, T1. So what's pressure? M1, L minus 1, T minus 2,
T
A.
minus 2.
The next is density. So M,
The
right?
density will be M1 L minus 3.
Yeah. M1, L minus 3. Energy, M1, L2, T minus 2. Now, what does it mean? Let's write for M first. M, A from here. In B, do we have in B? Yes. Plus 1B plus C. Then L minus A minus 3B plus 2C. T minus 2A 0B minus 2C. Now, what we'll do here, we will equate this on the left side, M0, L0, T1. So let's equate LM, L and T. So A plus B plus C from M equals to 0 from M. Don't writing this in exam, just for remembering. Minus A minus 3B plus 2C equals to 0 from L. Minus 2A minus 2C equals to 1 from T. So we got 1, 2, and 3 equation. We have 3 equation, 3 unknown. Can we solve this?
Yes, sir.
So we'll see about that.
Okay, try this as a homework. It will be long.
Okay.
I want you to take your time, get this answer correct. And second one, I'm going to give you again list. Do we have self-inductance? Yes, we have.
Sir,
Yeah,
do A, B, and C have to be whole numbers?
yeah. This not whole number. It will be in like fraction.
Yes, sir. I'm getting B as 1/2.
Yeah, no problem. Okay. Do this solution at your home. And one more question I'm giving you. So question, here we go.
So I'm getting B equals to 0.
It won't be 0. No, it can be 0, but I don't think so it's 0 here. Okay, write down this question. No, wait. Yeah. Dimension for self or mutual inductance. Check this question. Solve it as homework.
Okay, sir.
By the way, do you know the formula? That is the problem. No, we don't have in this one. Okay, then let me give you a formula. Yeah, I have to give formula. E equals to L di by dt.
Sir,
Yeah.
I got the values for the above three equations.
Oh, you got it.
Yes, sir.
Let me
B
write.
is 1/2, A is 1/2, and C is -1.
A is
A and B are both 1/2, and C is -1.
okay. You don't think so?
I'll double check, sir.
Yeah. Here answers are different something. Okay. No problem. You can check it. But read this question. Yeah, E is induced electromotive force. That means EMF.
Yes.
DI is current. So that in short, we need here L equals to E dt by di, which is equals to W by Q T by I. Okay. After this, I cannot give you. This much only I can give you. W is work done, Q is charge, T is time, I is current. Okay, I'll not give you more than this one. This is
So
maximum.
W,
You need to find L,
no, W is,
work done.
okay.
Make a note of
for
this.
homework, right?
Yeah, this is
Yes.
homework.
Okay.
Already
This one.
half I did.
Okay. Cool.
Because you don't know formulas, no? That's why.
Okay.
Okay, guys. Done? You wrote everyone?
Yes.
Yes.
Is anyone writing?
No.
Aditi, Rahman,
Done, sir.
done. Samhita,
Answer.
are you writing?
I already wrote.
Oh, okay. Okay, guys. Then let's